I will give you some suggestions, and I have discussed that if fz is differentiable, then fz bar at z0 is differentiable at z0, then fz bar z0 equal to 0. This was a theorem, so this is very important. And analytic function. So analytic in a set S, or analytic at a point z0 means if this function fz is differentiable at each point of some neighborhood of z0. So if this is a z0, so the neighborhood of this z0 is this. So if this function will be differentiable at each point of this neighborhood of z0, then we call this function is analytic at z0. And whenever this function is analytic at every point of a domain D, then we say fz is analytic in D. And whenever this function is analytic throughout the complex plane, then we call this is fz is entire function. So these concepts are very important. So analytic or differentiability of a function are closely related. So by using, I have solved two questions from which we can say the non-differentiability of a function which is given in the form z dot z bar. So if you are given a function in terms of z bar, so you find fz bar. So if this is not equal to 0, then we can say f is not differentiable. This is differentiable, then it will happen. If it will not happen, we cannot say this is not differentiable, but contrapositively we can say if this is not equal to 0, then we say if this is not differentiable. So we apply this theorem to show non-differentiability of a function. Okay. And I have proved one theorem that if fz equal to uxy plus ivxy is differentiable at z0 equal to x0 plus iy0, then their equations are satisfied at this point z0, or generally you can write for this, if this is differentiable, then I into f of x z0 equal to f of y z0, and from which you can find u x equal to vy and uy equal to minus vx at z0. Okay, so this is CR equation, and this is the complex form of CR equation. This is Cartesian form of CR equation, and there is also polar form of CR equations. So this theorem is very important. So I have proved this theorem. So see what happened in this proof. So this is very important theorem. And also I have discussed, if you are given a real complex number x plus iy, and then find something like principal value of z, that is defined as argument z. So this is also important. And the converse part of the theorem, that is you are given fz equal to uxy plus ivxy, and asking that so that fz satisfies CR equation at z0 but not differentiable at z0. This type of question is very important for your exam. So this is general questions in previous year exam. This type of questions were given. So sometimes you are given that fz equal to in two form. This is u xy plus ivxy whenever x comma y not equal to 0 0, and this is 0 whenever x comma y equal to 0 0. So this type of question is very important. So solve. So I have discussed some problems like this. So these problems are very important for your next exam. And also harmonic conjugate. Even I also discuss harmonic function. So phi will be harmonic function if del square phi del x square plus del square phi del y square equal to 0, that is Laplace equation. So this is Laplace equation. And harmonic conjugate function, harmonic conjugate of a harmonic function uxy will be v of xy if f of u plus iv is analytic. I have solved one question where u is given and you have to find the harmonic conjugate vxy. Okay. So whenever u is harmonic function, v is harmonic conjugate. So related this concept harmonic conjugate, there are some theorem. So and regarding this, you have to clear uh, knowledge about this to solve some problems. So if you are asking v is a harmonic function, find that f analytic function. Then how you will solve? So this type of question you have to tackle. I will solve one question in which CR equations are satisfied but not differentiable. Okay, this type of question I will solve one question which is different but very easy. This is very interesting thing and this is very important. So this is analytic or will be analytic if V is harmonic conjugate of a harmonic function u. So whenever V is a harmonic conjugate of harmonic function u, then f equal to u plus iv. So here is harmonic and here is harmonic conjugate. So this function will be analytic. So we multiply with I. So this will also analytic. We multiply minus 1. So this will also analytic. Okay. So we get V at this. So if we can compare with this, so whenever V is harmonic function, minus u will be harmonic conjugate. Okay. Such that this will be analytic and similarly this will be analytic. So this is very important results. You can use this whenever the question is asked in a different way. So now we solved one question. So let us fz is defined as real z and into imaginary z modulus to the power half. This will satisfy CR equation at the origin but not differentiable at this point. So simply for that we know x equal to x plus iy, where this is real z and this is imaginary z. So from this we can find function z, that is xy, equal to, this will be x, this will be y, x into y to the power half. So if we write as xy plus I into vxy, so from this we comparing we get uxy equal to this and vxy equal to 0. So therefore Vx00, Vy00 will be 0 clearly, but Ux00 we have to find. So if you find limit h tends to 0, this will be U 0 comma h, that is h comma 0 minus U00 divided by h. So from this, if we put h in the place of x and 0 in the place of y here, so we get this is 0 and this is h, so this will be 0. Similarly, uy00 also will be 0. So all partial derivatives is 0. Therefore, ux00 equal to voy00 and uy00 equal to minus vx00. So at 0, CR equations are satisfied. This is the first one. So simply fz satisfied CR equation at the origin, but fz is not differentiable. Now prove this. So to be differentiable, this fxy limit f of z plus h, that is z is origin, that is 0. So this will be h 0 plus h minus f of 0 divided by h will be need to be path independent. Fz to be differentiable, this limit should path independent. So now we see this difference is path dependent or path independent. So for that we choose h equal to is a complex number, that is we choose r into e to the power I theta, that is x is r cos theta, y is r sin theta. So this is r cos theta plus I sin theta. So now we put here, so h equal to nothing but h equal to x plus iy. Okay, so we put here, so limit h tends to 0, and that it will be r tends to 0, this will be r tends to 0, and f of h, so if you put here, so we get that is x y, so x into y, this will be r square sin theta cos theta to the power half minus f of 0, that is if we put 0, so this will be 0, so f0 equal to 0, fh equal to this, so divided by h means r into this, r into e to the power I theta. So from this we get limit r tends to 0, so this will be r square, this is sin theta cos theta to the power half, so this will be r and this is r cancel out, so from this e to the power I theta can be written as this, and if we put root 2 in both sides, if we put root 2 in both side here, so we can take here as 2 sin theta cos theta to the power half and under root 2, so this can be written as, so this will be limit r tends to 0, and this is minus I theta, and this will be 2 sin theta cos theta, that is sin 2 theta to the power half divided by root 2. ठीक है, so this limit becomes like this. So this limit depended on, so the limit dependent on theta. So for different value of theta, we will get different values for the limit. So that's why this limit become, but the limit is a path dependent. So this is circular path dependent. So this is path dependent, so this limit does not exist. That's why we can say this fz is not differentiable at the origin. Okay, so this is very important problem. I have skipped this problem when I discussed the theorem, so this is very important for your exams. Thank you for showing your love. I will expect more likes and comments. Share with your friends so that they can be benefited from my lecture videos. Thank you very much. Like and comment कर देना वीडियो पे तो मुझे लगेगा कि तुम लोग देखे हो. So for today that's it. I will upload video after Durga Puja. For that, keep learning, and I will discuss later for end semester also. So before that, share with your friends so that all of your friends be connected with me. So thank you very much.